All right, we are going to finish up the 3-5 notes. Okay, the directions say, what are all the real and complex zeros of the polynomial function shown in the graph? So, here's the polynomial function that they give us, and the graph that they give us has an x-intercept here at the coordinate point 2, 0. Now, I know that if I have an x-intercept of 2, 0, that means that I have a 0 of x equals 2, and it also means that I have a factor of x minus 2. Now, we do not have a way of solving quadratics, cubics, right? That's x to the third. But if I have a factor, I can divide that factor away and solve the remaining quadratic. So, let's divide x minus 2 away from this polynomial. My front porch number here is going to be a positive 2, and my coefficients are 1, 1, negative 3, and negative 6. We drop the 1. 2 times 1 is 2. Add 1 plus 2, we get 3. Multiply diagonal, so 2 times 3 is 6. Add down. Negative 3 plus 6 is 3. Multiply diagonal, and we get 6. With a remainder of 0. Alright, so this is how we can prove or show that 2 is a 0. Right? Okay. Now that we know that that is a 0, and we knew that because that was the x-intercept, but we can solve the remaining quadratic. So we went from polynomial form to coefficients, divide it out. Now we need to go coefficients back into polynomial form. Since this was x to the third, we take one down. This will be x squared. So we now have x squared plus 3x plus 3 equal to 0. And if we solve that, we'll have the remaining zeros for this function. Now, I know that since we turn twice without touching the x-axis here, that means that these are most likely, no, they are in fact going to be complex. So, I know I cannot factor this, and if I cannot factor, in order to solve a quadratic, we use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Our b here is 3, a is 1, and c is 3. Now cleaning this up, the opposite of positive 3 is negative 3, plus or minus the square root. 3 squared is 9. A negative times a positive is negative. 4 times 1 is 4, times 3 is 12, all over 2, times 1 is 2. Alright, clean that up. 9 minus 12 is negative 3, so we get negative 3 plus or minus the square root of negative 3 divided by 2. Since the value under my radical is negative, we have to poke the I out. So we get negative 3 plus or minus I root 3 over 2. And now, all of the zeros, right? We showed that 2 is a 0. So I'm going to list all of my zeros here. We have 2, and negative 3 plus I root 3 over 2. And negative 3 minus I root 3 over 2. So that's 1, 2, 3 zeros, and the degree is 3. That matches. There we go. We have complex zeros where the graph turned below the x-axis. All right, let's try that one more time. Take a look here. We have a function is 2x cubed minus 8x squared plus 9x minus 9. And we have to find all the real and complex zeros. Well, they gave us one of those zeros here, right? Crosses the x-axis at 3. So let's synthetically divide out a 3 here. Our coefficients are 2, negative 8, 9, and negative 9. I don't know why I put a plus right there. We don't need it. Alright, drop the 2, multiply, we got a 6. Negative 8 plus 6 is negative 2. Multiply, we get negative 6. 9 minus 6 is 3. 3 times 3 is 9. And now we have proven, right, we can show now that 3 is indeed a 0 of the function because my remainder there is 0. So I need to translate from coefficients back into polynomial form. This was 2x to the third, so we take 1 down, that'll be 2x squared minus 2x plus 3 equals 0. Alright, now we have to solve this, and I can tell you, just by looking at that graph, alright, it turns twice before touching that x-axis, so those are going to be complex, so we're going to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. B here is negative 2, a is positive 2, and c is 3. Cleaning this up, the opposite of negative 2 is a positive 2, plus or minus the square root. Negative 2 squared is a positive 4. A negative times a positive is negative. 4 times 2 is 8, times 3 is 24, all divided by 2 times 2, which is 4. And 4 minus 24 is negative 20, so we get 2 plus or minus the square root of negative 20, all divided by 4. And if you want to use your calculator here, yes, I suggest that you do. If I could find mine, we'd be in good shape. So if I use my calculator here, we're going to clean this all out. Using my calculator, if I put the square root of negative 20 in there, it's going to tell me it's not real. I know that, right? The I has to come out. So what would it reduce to if I just did the square root of positive 20? We get 2 roots of 5. Alright, so we get 2 plus or minus 2I root 5 all divided by 4. And now my 2, 2, and 4 all reduce. So 1 plus or minus I root 5 all over 4. So the zeros are 3, 1 plus I root 5 over 2, and 1 minus I root 5 over 2. So all 3 of our zeros. If I'm going too fast, that's okay. You can absolutely pause to catch up. Alright, same story here. We have real zeros of negative 2 and positive 2. And I have my original function here is x to the 4th. So I need to end up with 4 total zeros at the end of this thing. So let's divide these out and see what we get. So negative 2 is going to be my porch number. And now my coefficients. I have 1x to the 4th. I have 0x to the 3rds. Negative 3x squareds. I have 0 x's and negative 4. Drop the 1. Negative 2 times 1 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is 4. Negative 3 plus 4, we get a 1. Negative 2 times 1 is negative 2. And 0 and negative 2 is negative 2. Negative 2 times negative 2 is a positive 4. And negative 4 plus 4 is 0. Now, here's what's really, really cool. Instead of translating this back into a polynomial just to divide out again, I have 2 real zeros. So I'm going to extend this into a second-story house. And my new porch number is a 2. So we drop the 1. 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0. 1 plus 0 is 1. 2 times 1 is 2. And negative 2 plus 2 is 0. So that proves that negative 2 and 2 are zeros of this function. Now, we have to translate this back into polynomial form. That was x to the 4th, right? So we had x to the 4th here, so that was x to the 4th. Take 1 down, pass it around, that becomes x to the 3rd. X to the 3rd, we take 1 down, pass it around, this becomes x squared. So I now have x squared plus 0x plus 1 equals 0. That we need to solve. And we can do that relatively quickly. Subtract 1, x squared is equal to negative 1, square root and square root. So x is equal to plus or minus I. Our zeros for this function are 2, negative 2, I, and negative I. Okay. Cool. Here we go. Let's try another one here. What are the solutions to this equation? Good gravy. So we have 2x cubed plus 5x squared minus 3x equals 3x cubed plus 8x squared plus 1. Now we got to go solve this, and it gives us a hint. Rewrite it in terms of 0. All right, so x cubed is my largest exponent. I want that to be positive just out of habit. So I'm going to subtract my 2x cubed. Subtract 2x cubed. I'm going to subtract 5x squared. Subtract 5x squared. I'm going to add 3x. Add 3x. So when I clean all of this up, I get 0 on the left side. 3x cubed minus 1x cubed is just x cubed. 8x squared minus 5x squared is a positive 3x squared. And then I have a positive 3x and a positive 1. 1, 3, 3, 1. That sounds like binomial expansion if I've ever seen it. Alright, so we got to go figure this out. We have to figure this out. How on earth are we going to get all of the zeros out of this thing? X cubed. I don't know how to solve that equation. So what we're going to do is we're going to use our calculators. And we need to go graph it to see what we get. So we go to our home base. I'm going to graph. Let's clear that out. I don't need you. So we need x to the third arrow. 3. Oh, we need a plus. Plus 3x squared. Arrow that over. No, arrow over. Arrow over. Okay, good. Plus 3x plus 1. And now that I want to go graph. So hit OK, OK, OK. Go graph. Go graph. Ooh. It's right there at negative 1, right? So let me just make sure. Negative, no, that's negative 1. For all intents and purposes, we got a negative 1. Now, if I want to calculate it, I can. I go over here to, go here to calculate, I hit OK. My Y value is 0. Okay. Yeah. So, when my Y value is 0, what does it kick back at? Oh, it doesn't really tell you, does it? Yes, ma'am.
Extension cord?
Yep, it's right here. Nope, it's on my desk.
Okay,
I'm sorry.
No, you're
so sorry. That was on my short list of things to do today.
Gotcha.
I want a 0 here for. Oh, I get it. I get it now. I know how to use these things. Calculate. Go to find zeros. Okay. Still kicks back with negative 0.99999. What that tells me is that negative 1 is my 0. So let's see if we can do this. So put a negative 1 out there. My coefficients are 1, 3, 3, and 1. And then we're going to drop the 1, so we get a negative 1 there. 3 and negative 1 is 2. That's a negative 2. We get a 1. Negative 1 and 0. Sweet. And now we translate. That was x to the third. We take 1 down. That's x squared. So we get x squared plus 2x plus 1 equals 0. I can factor that. X plus 1 times x plus 1 will give me a 2x in the middle. Set each one of these equal to 0 and solve. Right? So x plus 1 equal to 0 is negative 1. All of this is to say x equals negative 1 is the solution. We could also say this for p of x equal to x cubed plus 3x squared plus 3x plus 1. We could rewrite that in factored form as x plus 1 cubed, right? And we have zeros. X equal -1 with a multiplicity of 3. Right, that's all the information that we got out of this thing, right? We know that that's the solution because of the way we had to solve it. But I also wanted you to know we ended up with -1 as a multiplicity of 3 for this thing. All right, keep cruising. Again, if this is too fast, you can pause and move forward if you want. All right, so what are the solutions to this equation? Well, that actually might turn out to be pretty nice. Because here I have x to the third, and here I have x to the third. So what I'm going to do is I'm going to subtract x cubed from both sides. And now we have -7x plus 6 equals 5x squared minus 2x minus 24. So when I add 7x and subtract 6, add 7x, subtract 6, we're left with 0 equals 5x squared plus 5x minus 30. Now, what do all three of these guys have in common? They all have a 5. So if I factor out a 5, not an x, but a 5, I'd be left with x squared plus x minus 6. Oh, good gracious. Because I do not have a variable with this factor, I'm going to divide it out. So I get 0 equals x squared plus x minus 6, and that we can factor. X plus 3 and x minus 2. So our zeros are x equals -3 and 2, and these are the solutions to that original equation. Alright, let's do one more. Here we have x to the fourth plus 2x squared is equal to -x cubed minus 2x. Well, this tells me I have to get everybody over to that x to the fourth as my biggest exponent. So I want to get everybody over to the left side. So we'll add 3. No, we won't. We're going to add x cubed and add 2x. So we're adding an x cubed and a 2x, but no like terms. So we get x to the fourth plus x to the third plus 2x squared plus 2x equals 0. Now, they all have at least one x involved, so I can pull out an x, and I'd be left with x cubed plus x squared plus 2x plus 2. And now with this guy, I would not know where to start. So let's just handle this piece first. I know that x equals 0 is one of my solutions. And now in theory, I would set all that equal to 0 and solve, but I don't know how to solve that right off the top. There's a special type of factoring, but we haven't gone over that factoring. So what we're going to do is we're going to plug in our calculator and find any real zeros. So where does this cross the x-axis? All right, so we go back, go here. We're going to clear that out. I want x, nope, not you. I need x to the third, not there, over, plus x squared over plus 2x plus 2. Alright, so where that crosses the x-axis, that's going to tell us a real zero that we can factor out of this thing. So we'll hit OK, we go over here, and we graph it, and where does that thing cross the x-axis? So, crosses the x-axis at -1. That's my zeros there at -1. Alright, so take -1 out as my front porch number. We have a 1, a 1, a 2, and a 2. So we drop the 1, we get 1. -1 times the 1 is -1. 1 times -1 is, or 1 plus -1 is 0. -1 times 0 is 0. 2 plus 0 is 2. -1 times 2 is -2, and we get a 0. Now I have to translate from coefficients back into a polynomial. That 1 came from x to the third. So we take 1 down, and now we have an x squared. So x squared plus 0x's plus 2 equals 0. And that's the equation we need to solve. You can subtract 2 because there's no middle term. We get x squared equals negative 2, and we square root that. I have a negative square root. So we got to poke the I out. So here x is equal to plus or minus I root 2. So all of our zeros, right, that's the real zero that we had. And that, so we have the zeros. And these are your solutions to the equation. But here we have zeros of 0, negative 1, I root 2, and negative I root 2. 4 zeros, the degree was 4.